One more set of notes.
Good morning, everyone. Good morning, everyone.
Good morning.
All right. I was worried you were still asleep after working so hard last night on these exciting new recommendations and roadmap that you were working on. I don't know how many of you did like I did. I woke up at 2:30.
Started scribbling notes.
I started making notes again, but anyway, I have my notes. I hope some of you have yours, but today we want to start off by getting some feedback from you, and we've got this shared vision up there, and we thought, well, we haven't asked for your feedback on that yet, and so one of the things we could do is see if any of you have any feedback on this particular vision, or do you generally agree with it or not agree with it, and any comments that you'd like to make would be welcome at this point. And then also we asked you to do some homework last night, and that is, make some notes, think out of the box, so to speak, and help provide some elements that we can discuss in our breakout 4 today on what this roadmap should look like. And so we'll see if there are any comments on that, and then we'll go through the program and get started on that. Cynthia, do you have any additional comments?
Yeah, I wanted to just give a couple of feedbacks on a couple of topics. I thought we had really good discussion yesterday afternoon. Just maybe two things. One is about the question that came up about international and smallholder versus sort of quote, but in quote, versus domestic, national, and focus on USDA. And so from the AGMIP point of view, AGMIP is committed to developing a global roadmap for the data model integration. And we really do think that the elements of that roadmap is probably, as Molly brought up in her very good comment, really is the same. There isn't really a difference between what is needed technically and technologically to work in any agricultural setting with data and models. So with that larger framing of the whole spectrum of agricultural activities, this workshop is really focused on the use case of the USDA CAP and NIFA and other projects and ARS. So the use case that we're primarily focused on here, and we're working on in the nuts and bolts sessions as well, is our USDA use case. But always with the back of our mind, what we're developing here, we very much hope would be, and I think really logically could be used globally as well. We also seem to have, there is a smaller group of folks who are here on the genomics, and we might want to talk with you folks about whether you'd like to have a small group on a roadmap for linking the genomics and the crop modeling, because that does seem to be a use case that we do have here. And if there are any others that are here, let us know if small groups want to meet. This is a workshop. It's really what arises and what we should focus on. So that was some feedback that we wanted to give on some of the discussion yesterday. And then I just wanted to put out some thoughts. These are my notes from the middle of the night. About as we come to work together across all the projects, and what works when people work together? What makes things work? Well, of course, as of course, all the program managers in the room are going to know what the number one thing that makes things work is, of course, is funding. But beyond that, in terms of why is data and model integration a good idea for people? You know, what is it that someone, for example, in a CAP project, then, you know, why might this be good for them? So we're really dedicated to having everything be good, you know, be good for the people who are involved. Otherwise, there's no point in having any kind of network activity. So some of the reasons, and I know the modelers in the room will have thought about this a lot, but maybe some of the data collectors, you know, we really want to find that integration and a way to work together that can be really good and positive for everybody. So some of the reasons that a data provider might want to be engaged in the shared vision have to do with, first of all, opportunities for greater attribution, greater distribution and attribution of the data sets that you all are working so hard to collect, that the CAP projects and others are working so hard to collect. Because a big part of this is really changing, as we talked about yesterday, changing how databases are recognized and attributed, and that they need to be absolutely, and this is an activity, this activity can be really a kind of guiding, you know, sort of a bellwether, that's the word I'm searching for, a bellwether of we're about really seriously attributing and honoring that data collection. So that's one thing. And then, of course, if the data are used in models, it's utilizing them in a way that can potentially be compared with other sites. They could be, if you have 4 years of data, let's say, then those 4 years can be embedded in a 30-year time series. So you can really get a perspective on the 4 years that you were working in the field compared to the 15 years for, let's say, on either side. The lifetime of the projects can be extended by having this data archives, and this, not only the archives of the data, but the use of the data. Then maybe to end with the area that I work in the most is climate change. And by having these really great data sets used in the models, it is going to really help both our nation and the world understand how a changing climate stresses, as Ann Bartuska was saying yesterday, are affecting our agricultural systems. And so it's really this is such a tremendous contribution from the projects that of providing these data that can be really, we very much hope, good for everybody involved. So those were my thoughts overnight.
Okay. So you were up for a while.
Yes. If I'm nodding off, please forgive.
Okay, so we have a microphone that we're going to hand out if you're talking today, so the people who are on the phone or the video can hear. And so are there comments on this particular? Oops.
Okay. Oh, I'll bring it back. I was getting a blank slide, but let me get back to yours. Let's first take any thoughts on the mission.
Any thoughts on the mission?
Is it open? Okay, here? Yes. Okay. Yes.
No, that's Simon.
Did I use it? Okay, got it. Anyway, I'm from NASA, so every morning we have to look at the mission. We have to revisit the mission.
So are there any comments on this? Okay, here's a comment. You gonna take notes?
Yep. Taking notes.
It's probably not a popular thing to say, but the two words that caught my attention in the mission was maximum recognition. I thought that was like a very prideful thing to say. And I'm thinking that maybe perhaps the idea behind that was the maximum impact of the data sets.
Okay.
For the amount of resources and money that goes into collecting them is definitely the, I think, goal of doing these kind of aggregated, coordinated data sets that's available to everyone. But I also underlined the politics of the connection with the scientists and their data and how hard it was to get it, to quality check it, and that recognition has to be in the form of a data set being equally important as a publication, or even more important than publications when you consider the impact they have on other people and what they can be used for. So that kind of caught my eye as what do we really mean by that? But I think the AGMIP effort in general, two of the president's initiatives, the one in big data that the additional resources go to, and also the climate hubs, are two areas that are really where AGMIP can focus. If we had the climate hubs focusing on the different data sets that are actually registered in terms of predictive climate, and I don't know what network to link into that, but we do it individually at a local level and just go ask NOAA for our downscale data sets to run our models with. But certainly the big data is where we can contribute and perhaps get that funding source that you said, we can't do anything without some funding, and it's very difficult to just do it on desire and not have the time and resources to do that with. So
Okay.
Perhaps we could work on that maximum recognition.
Sure.
I fully agree. Good comment.
Somehow quantify that a little bit more in terms
Yeah.
of the impact of the data set.
Yeah, good comment.
Thank you for taking the comments, and then you
Yeah,
can
there's-
to revise during the day and show that we didn't forget something.
I looked at this from the other perspective, which if I read the minimal disruption to research activities phrase, that tells me that producing data and making the data available is not part of research, because we are disrupting research to be able to distribute data. I think there's a fallacy in that assumption, and I think we should say something about it, make it easy to share research or make it easier or efficient or something like that, not disrupting research to provide the fruits of their data that the people of the United States have paid for, if we want to put on the, the free and open data hat.
Excellent. I mean, I'm glad we opened it up for this points. I agree with that also. Very good. Oh, and another one. Great. Here's
This is like the climate change negotiations.
Indeed. And so for me, I guess it's just a question about how you're thinking about this in the long term, but the distributed network, are you thinking about some underlying common infrastructure here? Because I come more from originally from the genomics plant community, and for us, iPlant has been quite helpful in that we have one place we can store data, we have models sat there, we have pipelines sat there, people go in, you can see what people are doing, and it's that shared infrastructure. And in fact, it's so useful that we've just also brought it over to the UK. So it's not only here in the US, but we're trying to have a shared infrastructure across the pond as well. So it's just, when you think about a distributed network, it's not that to change the wording, but what are you thinking about in the long term? To me, that doesn't say it's linked. It doesn't say shared. You know, it's more of a question than changing what's there. So.
Yeah, and let me comment on that, because the intent is that it would be linked and compatible and harmonized. And my own vision, and we've talked a bit with Simon as well, is that the National Agricultural Library would be the main repository. But then there are always groups of researchers and scientists out there who have already their databases. Like in Idaho now, they have a really good database already set up there, and we want to link those. So I think we need to clarify that to make sure that it's done. We could even emphasize a primary data node with linked network or something like that in some way. But yeah, Sarah.
Thanks. I was just going to follow on that. That was a similar thing that I was thinking about reading this. And the place that I might tweak it a bit would be the harmonized for easy discovery. That's the bit that could include something additional like cataloged, or something that tells you that there is one place that it's searchable, even if it's a distributed network.
Mm-hmm. Okay. Yeah, that's very good. A portal. And again, the portal here would be the National Agricultural Library. Simon, I hope if you disagree with this, yeah, go ahead.
From the first parts, it says networks of crop databases.
Mm-hmm.
That's really limits to the crop databases. It needs to be more agricultural-based databases. It could be animal, it could be forestry,
Absolutely.
It could be anything like that.
Perfect. Absolutely. I think, Lori?
Hey, Joe. So I think what AGMIP is aiming to accomplish here is really great and really good in a lot of ways, to bring all of these groups together and try and harmonize our data. So I think it's probably just a different way of looking at the same coin, or kind of flipping the coin, is that there's a national data initiative originating from NAL, and AGMIP is a subset or a user of that data. Because I think of us as CAPS, like we have these huge data sets. Some of them will be useful for crop modeling, but there's other data that doesn't have a place in those crop models as of now. So to have kind of a broader, larger vision, but that probably goes beyond what AGMIP is interested in also. So what is our broad understanding of agro ecosystems, and how do we store the data, use the data, create this platform initiative, and then how is AGMIP maybe a subset of that? But obviously that probably goes beyond the goals of this workshop too. But there's a huge amount of data, as we've all discussed, coming from ARS that already exists from the CAPS, which were to create these legacy data sets that, and then how everyone, every PI at every institution has a lot of data too. So there's obviously a lot of data in existence that could go into this platform, but then how do we think about large agroecosystem data sets that go across water, go across crops, soils, weather, greenhouse gases, all these things, and some of those data don't have a place in AGMIP. So, yeah,
that's a good point. In fact, I don't know if we'd want to put it in the top level statement, but I think somewhere down there we should have sort of roles of the different groups, and certainly AGMIP can play a role not only as a user, but I think also as a contributor to the development, to make sure that it is compatible, at least across the models and many different models. And that's really what we've already invested a lot of time and effort in. We wouldn't want it to be developed so that someone has to reinvent those wheels. But certainly our vision all along has been that the National Agricultural Library would be a repository ever since Simon visited us a year and a half ago in Gainesville. So other comments? Yes.
Oh, thanks, Jim. I just wanted to reiterate what Lori was saying. Is I completely agree, and that I think that what I have seen looks to be a great structure to be able to kind of replicate out maybe into these other areas. And I think that I'm seeing a lot of potential collaboration in these, not just in the crop modeling area, but in these kind of peripheral areas that have the exact same problem. And so you guys have spent a lot of time in the kind of infrastructure, technology development, and I think Chris has done an amazing job. And I bet that that modular structure could be kind of envisioned maybe in a bigger picture and kind of stamped out and then kind of coalesced together. I think that would be a great model for the USDA. And that, I think what you guys have done could then be kind of maximized across all those areas.
That's exactly what we hope will happen. Yeah.
Yeah, it's the focus of AGMIP is the M in AGMIP stands for model. So that is our focus. And one thing, it's real, there's some good things about that because it actually then energizes around an actual use case, right? It's actually that there are modelers who are just, really, really excited about all the great data coming from the CAPS research programs and projects. So that it makes it so it's this actual concrete need that can then get going so that then, as you just said, that then what we learn from doing this can then be, we hope, can contribute to the use of the discovery and open access and use of other types of, in other uses.
And in addition, we need to help make sure that the community comes together to get this message out, because it's going to be us that does it. I mean, all of us. It's not just AGMIP. I mean, and so I'm glad this came up this morning. It has to be a full community, each one with our roles to play, contributing to this, because I think we have a chance to do this. I really do. And but if there's going to be, issues and all, it's going to create more bottlenecks, and so we want to get rid of those. We want to really have a successful system. So I think we're eating into the time a little bit, but we can postpone break for 30 minutes. So maybe we could start Simon's talk at, it's supposed to start at 8:45. So maybe we can start, should we go ahead and start it now?
I think that this was a really good discussion, and let's turn to Simon.
Okay. So this morning we have Simon to start with, and he's going to be talking about the potential roles of National Agricultural Library in harmonizing USDA data. Exactly one of the topics that you raised. So Simon, we look forward to hearing your comments.
Your thoughts.
Yeah.
And your vision.
Yeah.
Well, good morning. I think I changed the title a little bit. Rather than harmonizing the data per se, I'm kind of using the words that yesterday Jim charging us. We need to come up with a roadmap for a national agricultural data network. So that's what I'm looking at it. So we all have the same dream to have a national agricultural network, and what are the potential roles NAL can play. Okay, so let me start with this thing. I'll give you an introduction and then tell you why we need to do so, and then how we're going to do so, and then I'm going to propose a logical journey. I'm not saying that this is a roadmap, but this could be a journey, and then it's really waiting for all of us to come together to expand this journey into a roadmap. So with that, let me start with this. I suppose you know this person. So this is what we have done in the past. When we do the research, we collect the data and then find the correlations and then publish a paper and then done with it. So that was the way we did it in the past. In the past, the way we did it, data was the precious commodity. We spent a lot of effort to collecting data. So in the past, we can say we are facing so-called data desert. Any research, we spend a lot of time to collecting data. But today, it's really, really different. We are really facing a paradigm shift in terms of our research today. We call the fourth research paradigm. The fourth research paradigm is that it's really, really data intensive. So we no longer face so-called a data desert. Instead, we are facing data tsunami. So in this data tsunami situation, how are we going to deal with it? Okay, so here are the things. Why we need to have a so-called National Agricultural Data Network? Because there are some reasons. One is the mandate. I kind of briefly mentioned that yesterday we have those three things from the federal government that become mandate. So as a result, all the federal granting agencies are really subject to those mandates. Those mandates are the stick. Remember, people talking about the carrots and the stick, right? So here's the stick. However, the stick is also provide carrot. For those people don't follow this thing, pretty soon they will be kind of retracting themselves from being eligible. That's meaning if you get a grant from NIH, if you don't comply with these things, your future prospect to get a grant will be diminished. So that means good for you, for those people comply with these things. So to some extent, there's a reward also. So this is the stick and also a carrot. And then also, not only for the mandate, we like to do resisting. We like to collecting the data to support our research, to speed up to advance our research, to speed up our scientific discovery. That's the whole purpose. But today, the research support is our research getting more and more data intensive. And our research getting more and more so-called computational intensive. Our research across multiple disciplinaries. And our research itself, people will begin to talk about open science, citizen science. If you can do it, I can repeat. Hopefully that's the case. I'm sure that this is a dream, but always some kind of driver for us to move forward. So I'm leading the USDA, the public access and open access policy implementation. So had a long conversation with Dr. Wataki, Dr. M. Bataska in the past 3-4 years. And I asked them one major question. What are our goals, main goals? Are our goals only limited to complying with the mandate? Or we are going to go beyond just complying with the mandate and then get into the holy grail of scientific data research. So this is so-called research support. And they say, no doubt, we are not only going to do the compliance with the mandate, but also we like to really create an environment, create a knowledge environment so that our people will be able to leverage the data we have collected in the past and then can continue our research and they can speed up our scientific discovery. One thing I kind of amazed when I talk to the research scientists within ARS, by the way, ARS, we have about 2,000 research scientists. So when I talk to some of them, I ask them one major thing. How much time do you spend to manage data? You spend 10% of your time to manage data, worry about data, do the computation, or you spend 20%, or you spend 30%, or you spend 50%. Imagining one person told me that he spent over 50% of his time just to manage the data, taking care of the server and so on. I say that's pitiful. The scientists need to focus on scientific research. They need to leave the data management to IT folks. Of course, IT folks need to kind of capable to support that. So the IT role in the past and IT role in today is different. In the past, IT to research is a supporting role. Today, IT to research is not only supporting, but also collaborating role. A lot of computation, a lot of data-intensive things. So the role of IT is really changed. And we need to embrace IT. So today, computer scientists, you need to learn different domain area expertise. Learn how to apply the computer science into agriculture, into genomic, into medical, and into many other different areas. So this is the so-called driver and need. Okay. So why we need to do so? Now, because of mandate, so the department right now is working on the policy. The policy related to the research result, there are two fronts. One is the scholarly publications. We all publish paper, conduct research, publish paper. All right. So the scholarly publication, here are, we call the draft policy. Again, you have plenty of opportunity to get input on this one here. For the policy here, the main thing of the policy, the first thing is who is responsible for making our scientific publication publicly accessible? Is the investigator and organization funded by USDA in this case, or funded by NIH, funded by other organizations. So if you receive the grant, you are responsible to make the grant research result publicly accessible. What to submit it? Well, it's the final peer review manuscript or published paper. By the way, for the USDA folks, when we do have the final peer review manuscript, there's no copyright involved. However, if you do the published paper, there's copyright involved. So we say, hey, either one will be fine. Where to submit it is the USDA Public Access Archival System. Later on, I'm going to talk about it. And then when to submit it is upon acceptance of the publications. And then they're subject to a 12-month embargo period. I put a 12 months here as a placeholder. Right now, this is our thinking. Again, this is a draft policy. This is our thinking, 12 months embargo period. The reason why we have 12 months is because NIH has been kind of follow this policy for many years. So we don't want to open another front to fight. So 12 months. So this is the so-called scholarly publications. This is the paper coming out of the research. All right. So the data. The data, who is responsible for? The same thing. What we need to submit. Here is the key question. What are we going to submit? The raw data or the final data associated with the publications? So here we kind of put a so-called high value data set. It's really unwise for us to say, hey, you need to submit this and the raw data of this and this. We put it there, so-called high value data set. And also the metadata associated with the data set. The metadata associated with the data sets is so important to make the data useful. And then where to submit it is the, I'm glad somebody mentioned about cataloging. Okay. Later on, I will kind of expand a little bit more and recognize the public accessible database. Jim mentioned that there are so many databases out there. Data is very different from publication. Publication is publication. They all the same format. Okay, PDF or XML format, the same thing. However, data, they have different standard, different format, you name it. And data is huge. The data volume is huge. It's so complex. So there's no one single organization that can handle all the things. So there got to be a distributed approach. University of Idaho have databases and other data, Purdue has databases. So we all need to work together as a community. All right, when to submit it? Again, here is the placeholder, 3 years. 3 years after you're completing the collection of the data. 3 years is subject to change, subject to debate. I invite all of you here to comment on this one. Again, I like to emphasize, this is only a draft policy. The final policy will listen to the stakeholder and then come up with something we feel comfortable. And then you all feel comfortable. Okay, so this is the data side. Now, to me, is that if our goal is a national agricultural data network, this data network need to have three major fundamental things, three major pillars. One is, hey, you need to have the scholarly publication. Second, you need to have a scientific data set. Those two need to link together. And then having data is no longer, it's not good enough. You need to have the model, you have the tools and other things so that you will be able to navigate and then to be able to visualize and analyze and compare and slice and dice the data and to conduct the scientific research. So those are the fundamental. Of course, there are some bells and whistles is so are needed, but fundamental of an ideal national agricultural network, you need to have at least those three major components. You need to have the data set. You need to have a data set. You need to have a scholar publication. You need to have the models, the tools associated with it so that you can navigate those kind of things. And all things need to be linking together. Stand alone would not work. And earlier I mentioned that the publication, they all similar format or the same format. So centralization makes sense, like a PubMed or PubMed Central in the medical field. However, the data itself is all different disciplines, so there's no centralization can do it. It's infeasible, impractical, and then impossible. And we don't need to reinvent the wheel. So as a result, distributed approach is really what we need. So I'm kind of glad that our mission statement say distributed network. That's right on the money. So here is I'm going to talk about here among those three things. We have the USDA and also National Agricultural Library. We have building block on those two areas. And I'm hoping with the AGMIP and others that we will be able to connect to it. Okay, let me get into this one first and get in here and then move on. Okay, so this is our PubMed. This is how I mimic the PubMed in the medical industry. You know, medical industry, PubMed or PubMed Central. PubMed Central is a full text databases. PubMed is the citation. So we are kind of doing the same thing in the agricultural field. So this is a PubMed. So PubMed is that here is the citation and the full text will be sitting here. You are a happy author. You can submit this thing through the submission system like you have with submit in a medical paper to NIH, or in a also, we are working with the publisher so that they can submit the article through this end. So our ultimate goal is this. We will be able to provide access to the scientific users, all the users, the general public, the researchers, and scientists, and professors, and so on. Now, behind the scene, this is very important. This is the authors, the control vocabulary. Ontology is one keystone to link those three triangles together. Without good ontology, you cannot do the computation. All you can do as a human being to interpret. That is too difficult. So ontology, this is for us to do the indexing, the tagging our article. So essentially, this is our solutions. The system is in operation now. And one thing I like to put in different color is so-called compliance reporting. In the future, once the policy is in effect, this system will output the report. We are working with the publishing industry, with the Crossref, the FundRef, and others. So if you are the recipient of a grant, you publish a paper, you need to submit it. If you don't have an entries here, just like you don't have something in PubMed. And then we are going to provide, provide these things. This is integrate, provide information with our granting system, CRIS, our grant system. So our grant system will be recognized. For instance, Jim, you got the grant from USDA. You published 2 papers. So we're going to come check here. Have you deposited your paper? If you don't, will be blank. And that will be disqualify you in the future. I shouldn't say disqualify, but it's going to impact your future prospect to get further funding. So that's the carrot. That's the stick and carrot also. Okay. Now, so here is the PubMed. PubMed, we say the system is in operation. Was soft launch last year and officially launched early this year. So this is the front end of PubMed, similar to Google things. Okay. All you have is a search box and you search it. So let me give you an idea of search. I search our leader, Jerry Hatfield. Jerry Hatfield, and it happened that Jerry Jerry Hatfield, we have correct 17 of his full text article. Again, this is early stage. Jerry must has published more than 17, but when I search this thing, you can search anything just like you search in PubMed. So this is our PubEd. Now PubEd for the time being, it's gonna include the articles published by the USD author. And right now we are in the process to include the article in the open journals and linking with PubMed and PubMed Central, so that in the future, those things will be interconnected together. Okay. Data. Data is a big different animal, big animals, big things that we need to deal with. Like I said, the data itself, there are so many databases out there. There's no point for us to reinvent the wheel. So as a result, a distributed approach is the way to go. Now, we all know this today. If you like to find a paper, you can go to library, go to PubMed Central, go to PubEd, you can find a paper, the citation. And or you go, if you go to, say, Google, you search and then go to the publisher, you pay for it, you can get it. Right? That's the way you do it. But think of data. Where can you find the data? Well, data is everywhere, nowhere to be found. Data might be in your laptop. Data might be in the server or the desktop in your laboratory. Only you or your peer or your close friend can access to it. If this is the way we want it, I remember that almost 6 years ago, I applied for the job of National Agricultural Library at that time. I interviewed with Molly Zhang at that time. Before I went to the interview with Molly Zhang, she sent me a book. The book titled 21st Century New Biology. Was published by National Academy of Science. And she wanted me to look at the book and to see how I think. I read that book inside out, every pages. And as a matter of fact, that book really promote the idea of what NCBI did. NCBI, you know, the genomic databases, GenBank and others. But the whole notion of that book is this. Don't reinvent the wheel. However, data is precious. Data is really precious. But if the data collect once, use only once, that's not good. Data has to be reusable. It's the reusability make data multiply its value. Data collect once, used by many times. Again, we all do research. Remember going back to the good old day when we do our PhD study? How much time you spend on data collection? I did. I must say that I spent a good amount of my time just to do data collections. Go through the IRB process, collecting the data, and you name it. Well, scientists do the same thing. Spend a lot of effort to collecting data, only use once. How pitiful that is. If the data can be reused and reused by many people, you can create an industry. You see the biotech industry created. The GIS data collect once, the GIS, the satellite data collect once, remote sensing data collect once, and used by many researchers. You create an industry. You create jobs. You create opportunity. So don't underestimate the power of data. So we are researchers. We need to really utilize the power of data. Reuse. Okay. So here's the idea of the data comment here. The data. We recognize those things, those data repository. Number one could be GenBank. This data repository. Number two could be Idaho. This data repository. Number three could be Purdue universities. If there are databases out there, good, we connect them rather than reinvent the wheel. However, data has nowhere to be found. We need to have so-called data catalog, scientific data catalog. This is where you're going to find the data. To solve the problem of data is everywhere, nowhere to be found. So what do you need to do? You are the data publishers. You are researchers. You are data publishers. What do you need to do? Well, this is the thing you need to do. If you're a publisher, let's say you are doing in Idaho, you do research. You got a USDA grant, you do the research. All you need to do is probably put the data here in the Idaho databases. However, put your metadata entry into the data catalog within the USDA, which the data catalog will be held here in this building. And so all you need to do is put the data you like to put, and just put an entry in the data catalog, provide a metadata. All right. So later on, I'm a data user. I like to find somebody did the research and put the data in Idaho. All I need to do is come to this data catalog and search. The data catalog will point me and say, hey, your data is in here. And then I can find it. So what happened if you conducted research, you had no home to go? What happened? Well, no problem. This is our concept. If you are a data producer, nowhere to go, still the same thing, you need to provide an entry into data catalog. However, you can put in here. The USDA catalog. This is we call a data common. Put the data here. If you have somewhere to go, go. If you have nowhere to go, come to us. Of course. They come to, there's something need to be curation. A lot of things need to go on. Okay. But this is the whole idea. Distributed approach. And collectively, we act as a community. All right. So here is the repository. I'm talking about this one here. Repository and those things. We have implemented prototype right now. This prototype will be used by LTAR. So LTAR data will be here. So here is our initial things, the ACT data commons, the beta version so far we have here. There are already databases out there. Our LTAR will be in here. And then within NAL, there are some databases we built, and they also connect to here. We have some insect genome databases, they connect to here. So again, the whole idea is this, a centralized place to search, to find the data, and point to different locations where the data reside. All right, so this is our data common. All right, with that, here is the data common. Earlier, people would say, well, if you look at the mission statement, we say, people come and say, hey, we shouldn't say minimize the scientific impact, right? Minimize the impact to the scientist research activity. Well, essentially, we like to kind of, when we create this data commons, we kind of concern about the scientist, your effort. Scientists, when they submit data, if the submitting data is troublesome, require a lot of effort from them, people don't want to do that. So we need to reduce the burden of scientists when they submit the data. Reduce the burden. That's the whole idea. Okay. However, maximize is the recognitions. That is the carrot. So here is this. We link in our prototype, we link the data set with the article. So this data set, I just kind of searched last night. Link the data set and find this is the article. So you can click here and go to the article. So in the future, it should be the two-way street. Go to the article, you can link to the data set. Go to the data set, you can link to the article. And then another thing is that people were talking about a contribution. Maximize the contribution, the recognition of the contribution. Well, our contribution usually you say your citation has been cited by this paper, how many, the impact factor, right? So this is the things that we kind of working with the publishing industry, try to come up with the DOI. So every data set has a digital object identifier. DOI will be just like a citation of your paper. When people use your data, they cite a DOI, and that means that they reuse your data set. And that will be the way to do the recognition. So the key thing is that linking the paper and article and the data set need to have the permanent digital object identifier so that you can not only establish a linkage and also establish a recognition system. Maybe in the future, when you calculate the impact factor, how many times DOI has been referenced will be one of the impact factors. And again, we are not working on this one in a vacuum. We are working with the publishing industry, and we are doing some kind of experiment here. All right, so final thought, the long journey. I mentioned to you earlier that James Jones charged this group to come up with a roadmap toward a national agricultural data network. I'm not saying that I do have a roadmap, but I do have a conceptual journey. And then hopefully this group of people will be expanding this journey and to make it a roadmap. But here's what I'm looking at. If you look at the so-called the conceptual things, that very important thing is that the data has to be locatable. Data and publication should be locatable. As I mentioned, data is everywhere, nowhere to be found. How can you locate it? Well, you need to have catalog somewhere. Just like a citation record, just like PubMed, just like PubEd. You need to have a catalog. But you locatable, it doesn't mean you can access, right? So we need to move up to so-called make it accessible. Well, how can we make it accessible? At least you need to have a storage store somewhere in the cyberspace. You need to have a server, provide some kind of computations, network, the metadata, and then search and download tools. We need to have this. Well, accessible itself is not good enough. We need to move one more step, make it machine readable. Because today, data is so huge, it's not comprehensible by human beings. You need to use the machine. So it has to be machine readable. Well, the machine readable is not good enough. We need to make it usable and reusable. Usable. Cynthia yesterday was talking about it's not useful, not usable, it's no use. It's no good. So usable, reusable, useful is so important. Reuse. Again, I'm kind of going back to the 21st century biology. That book, the central theme is the data collect once can be reused many times. That is the power of the data. Okay, reusable. In order to make it reusable, we need to have this thing. I like to emphasize here. Oh, by the way, if we like to make it machine readable, you need to follow standard. You provide an API. Jim yesterday was talking about API and so on and so forth. Again, I'm listing only the major component we need to have. Make it useful, reusable, ontology has to be there. Without ontology, I say corn, you say maize, who knows? We intelligent people, we know corn is maize, but computers don't know that. So as without ontology, ontology is a general term of control vocabulary, the thesaurus, and others. Okay. And we need to have discover tools and so on, the article data linkage, and also the curation. The curation of the data, make sure the data has high quality is also important. All right. The holy grail of the whole thing is a reproducible. This means that if you say, hey, I use this kind of data. I have this assumption. This is the thing I do it. This is my methodology. I should be able to repeat your scientific experiment. That's the Holy Grail. How long we're going to get there, we don't know. But in order to do that one, we need to have a lab node, assumption, and others capture. So looking at this one here, if we just go to the machine readable, we comply with the mandate. However, complying with the mandate is not our goal. Our goal is further beyond compliance with the mandate. Our goal is really supporting research so that each and every one of you as a researchers, you will be able to focus on your effort to advance the research using the tool available to not only advance your research, but also to speed up your scientific discovery. Instead of spend 20% of your time, 10% or 30% of your time to do the data collection, to do this kind of data management, you spend 100% of your time to do scientific research. So that's all I have. And then this is the journey. I think I invite you to comment and then expand it into a roadmap. Thank you very much.
So Cynthia and I were just talking about changing the schedule. First of all, thanks very much, Simon. That was very good. And I think it's consistent with what some of us were saying and have been thinking about. So we're going to change the schedule so that the summary status of dairy, beef, LCA, and other data will be done after break, if that's okay for people who are doing that. And we're going to take time for a few questions for Simon, and then we'll have Jeff give his talk before break as well. So Sun Ho, he's bringing the microphone.
Okay, I'll take it first. One of the difficulties in all of this is also keeping up with the IT world. So one thought I had going back to the publications, you have something like, say, Google Scholar. And just for fun, I went on Google Scholar while you were talking and came up with 40 publications for Jerry Hatfield with links to the actual publications and the number of citations for each one. And Jerry Hatfield didn't have to do anything for that to happen. He didn't have to submit his manuscript. Do you see, a way to tie into that kind of a search mechanism, and what does that mean for the data repository?
So there are distinctions between the Google Scholar and the PubEd. One is the Google Scholar, unless you have license, you cannot see the full text. That's the major difference. You go to Google unless you have license. Otherwise, you cannot see Jerry Hatfield's article. Now, another question is that why I have only 17 when you search, you got 40? Because some of the previous article, we haven't really scanned it in yet. So essentially, eventually, all the Jerry Hatfield publication will get into the database. So that discrepancy would address later on as we kind of expand the content of the article. By the way, the article right now we have in the PubEd, the full text article for the time being, at the beginning, we have about 60,000 articles. We are expecting that in the future, we are kind of outreach to others. So we'll expand that coverage. So that would be never an issue. For the linkage to the data from the article, I don't believe other folks will have this kind of capability to do so, unless they do, unless in the future, we imagine, in the future that the whole industry come to a conclusion that every data set has the DOI, everybody follow that. Otherwise, you will not be able to calculate the impact factor for the data reuse. So that is something that I like to, I think the vision here is to address that kind of issues. By the way, I missed something here. I'd like to kind of say that ARS right now has a big data initiative. We spend $5 million a year for 5 years, so a total investment will be $25 million to kind of put these things up. This is we call a scientific computing network, SciNet. there's a totally different network, and we connect to internet too. So currently there are 6 locations across the USDA ARS will be having access to will be connected to internet 2 community, and then we are kind of putting together high performance computing in Ames, Iowa. So this is something very exciting. Later on, the Act Data Common POP Act, we will leverage that as a part of the infrastructure.
Thank you for your sharing your excellent logical journey. I love it. Actually, I'm from international organization, so I'm not from the USDA, the people, but I'm just wondering about the linkage between data.gov and this egg data catalog.
Thank you. Data.gov, there are a few major differences. Data.gov primarily is a pointer, it's a catalog. Okay. Data.gov don't have linkage to the article. Data.gov don't have linkage to the tools and others. So you can think of data.gov. If I'm going to use it, don't quote my analogy, okay? Okay, don't quote. Data.gov might be a bicycle. We can get from point A to point B. But you like to go beyond a bicycle. You like to have at least a motorcycle or at least a little car. So that's the position we put, that our Act Data Common is at least a Hyundai car. Maybe later on become Toyota car. Maybe later on become Mercedes-Benz.
Yeah, I'm wondering, so how do we connect NIFA's RPPR, which is now report, which is the old CRIS system, to PubAg, since they're required to report their outputs, which would be publications and hopefully in the future data sets?
Yeah, thank you. This is a very good question here. If I can go back to this one here. This is the piece. This is the piece, the compliance reporting. We will be outputting this to your system. As a matter of fact, we do have an initial talk with your CIO, and then we create a protocol, define the protocol, and then that's the early version. Sunny comment on that protocol also. So that is the things that we try to link with your system.
Thanks, Simon. That was a great talk. And I'm really happy to see the draft policies, because I think I'm working on a daily basis with researchers that are putting into RFPs. And the language with respect to the mandates has been very vague in the RFPs. And it's not just USDA, it's actually across a whole bunch of different agencies. And also, there's really no explicit language about the amount of funding that people should be intending to put into their RFPs. And I think that those of us that are trying to work with data management, if that kind of language were in the RFPs, it would take a lot of pressure off of us that are trying to manage those cyber infrastructure resources. The second thing I want to say is that I participated a couple of weeks ago in an NSF Big Data Hub regional workshop, and there are actually four different regional hubs that are being developed by NSF. And part of what we actually discussed in the Western meeting was the fact that they wanted kind of some use case scenarios. And I think there's an opportunity here for example, AGMIPs to connect in with this developing cyber infrastructure on a national basis. And so I think there's maybe an opportunity to somehow connect to that. And then the last thing, it's kind of a question. Who monitors or who actually implements the stick? And, you know, I suspect your answer is that it's USDA. And I think that's fine, but actually at the true implementation level, it's these individual projects and the people that are working within these projects. And I think, again, the more explicit the RFPs can be in the language of what those expectations are, the faster we'll be able to put this whole vision into practice. And I think those are some things that would really help us out.
Thank you. Jim, should I go ahead and answer? Okay, so you have 3 questions. Let me do it in reverse order, the third one here. The USDA has a USDA Science Council chaired by Dr. Wataki. And within the Science Council, there's a committee on these things, the open access, public access. I am the committee chair of that committee. All right. So we are kind of working on the policy side. So the idea is in the future, when the policy in effect, these things will be a part of the term and condition for NIFA. So NIFA, your IP will have the term and condition specified that. Your research output should be making it available in terms of the scholarly publication and the data. All right. So here come with, well, you mentioned that there's no specific language to talk about it, and then the funding thing. The funding model need to be ironed out. Again, we are talking about a draft policy for the time being. A lot of so-called stakeholder meeting need to take place and make sure we come up with something everybody feel comfortable and practical. Okay. So one thing I like to use this picture is this. In the future, the term condition will dictate. That was the stick. Say your paper, your data set has to be available. How are we going to do that? The output from the system, PubAC and Act Data Common will provide this thing to the grant system. So the grant system will be recording, say, hey, this grant produced this paper, this data set, and then have they submitted to it? So that will be the stick, the enforcement. Who is going to enforce? It's ultimately is the funding agency, which provide data by those 2 systems. The funding agency need to enforce that using the information available, and it's up to the grantee, the grantee organizations. They need to make sure that happen. Now, as far as the vague language, right now we are working on it. For instance, we say, hey, you can. In the future, the NIFA grant, you need to submit a data management plan. As a matter of fact, National Science Foundation and pretty soon NIH will make it across, all right, data management plan. You need to tell me how are you going to handle data. So 2 weeks ago, we have a meeting with Purdue, Jeffrey and other group. And also last week, we have a group of university dean and come here. We're talking about we need to working on something so-called a template for data management plan. Hopefully this template will be adopted by NIFA and other funding agency. And then we can say, hey, if you like to apply for the grant, here's the template you need to fill in. And then another issue is that we say this is a distributed approach. This one existing one. Can you say, hey, my laptop is here, my laptop is this repository? Sorry, nice try, no cigar. All right, the database need to fit into certain criteria. So we need to develop those kind of criteria. What kind of database will fit in this profile?
I'm afraid we're going to have to continue. I mean, maybe you'll be in breakout 4 and we'll have some other chances to talk there. But thank you very much, Simon. I think you helped answer a number of questions and started us on a roadmap, actually. So that's very, very good. So let me introduce Jeff Olenek from Purdue, and he's going to talk about the Tri-Societies data initiatives. Jeff.
I'd first like to just thank the organizers for inviting us to be here. This is an exciting time to work on data and data thinking. I'd like to also acknowledge my cohort here, Sylvie Rodair, who's in India, couldn't be here today. But Sylvie's also a thought leader in this area, and I cobbled together some of her thinking for today's talk. Let me begin by just introducing the societies. Some of you may not be familiar with them, and so just very quickly remind you that it's really I work, or I'm representing Access, which is the overarching management group for the professional societies in the areas of soils, crops, and agronomy. Okay, and I used to be, not long ago, president of the Crop Science Society. The membership is about 10,000 active members, full-fledged members, and we've got about 1,300 or 13,000 certified professionals on the landscape. I'll come back to that because that's one of the drivers for data in our organization, serving their data needs. And it's something not often thought about, but it's interesting that Simon used medicine as an analogy earlier. I'll go back to the medical community because in our world, these really represent clinicians, medical doctors in the field in some ways, although they're not MDs and many aren't PhDs, they are practicing professionals at the interface of agriculture and science. We do a lot of basic and applied research, biophysical research. With these in-field professionals, we publish 10 journals, dozens of books and monographs annually. Here's one of them that is donated to the library yesterday by Cynthia. And you can see right along the bottom the societies are mentioned. And our members are keenly interested in data-related issues. And we're wanting to provide those services. A little bit about our data. It's complicated, okay? We measure a lot of inputs, things like sunlight, precipitation, fertilizers, irrigation, things like that. Traditionally, we're thought of as collecting yield, growth, feed, fuel, energy issues, nutrient removal. We monitor soil temperatures, that nature. We also do a lot of environmental monitoring, runoff, greenhouse gas emissions, down here leaching losses. So there's a lot of different disparate data streams that make our data interesting. People talk about the V's for data. We've got volume, variety, velocity, and veracity all locked up. I mean, there's no doubt about it. Some of the issues that are facing data generators and data users, we've talked about some of these here, and they're facing our society members. Standards, we talked about that yesterday. Minimum data sets. By the way, I will mention right now that it's like a deja vu moment. We're talking about harmonizing data. Well, this talk is really harmonized with our discussions to date. I mean, they're very parallel. And no, I didn't write this last night after yesterday's discussions. But the issues are much one and the same. And I think for that reason, working with NAL, working with AGMIPS for the Tri-Societies is just unnatural. We share the same issues here. Provenance issues, repository, data publishing, versioning, discovery and retrieval, granularity. That's a tough one. How granular do you want the data? Scholarship of data publishing. This is the attribution and the benefits piece. Ownership of data. Business models for data. There's a tough one. And education about data. I won't talk about all these, but I'll touch on some of them that I think are moving through the thinking of the leadership of the societies. And let's begin with data standards. That was a big discussion point yesterday. It will continue all week. Historically, with publications, we've had this nice little publications handbook and style manual, circa 1998, seems like ages ago. Jeff White says he still has one on his desk. Can't be found most places anymore. There might be one in the library here. You have yours, Cynthia? And so I looked in it. I said, what does it say about data or data standard? Well, it says nothing. So this hasn't been revised in a while. There's stuff over here in chapter 7. This is about a 120-page book. It sort of talks about standards, sort of, but nothing about data. So we don't really have policies or standards, really, explicitly. But maybe we don't need them. Wrong. Just so wrong. I'm sorry. This is just a 10-minute little glimpse into our journals. And I was depressed. I used to be editor-in-chief of some of these publications. And to see what's happening is just a little disturbing. Journal of Production Agriculture, these are just quotes right out of this talking about yield. If we're going to get one thing right, it's got to be yield, right? Correct? I mean, that's what it's about. Oh, God, it's scary. I'm sorry. Grain yields were converted to bushels per acre at 15.5% moisture. Very much a U.S. standard, not a world standard, but very common. Okay, so back in 1990, we're pretty good. Agronomy Journal last year, okay, 0% moisture in the grain. Okay, that's fine, as long as we know. That's good. We can calculate. We can do the math. It's pretty simple. Different article in Crop Science, 12.5% moisture, okay? And it's expressed in tons per hectare. I don't care. That's fine. Agronomy Journal, a different article, 14.5% moisture. Okay, different units, but okay, so we're getting different moisture levels. Get down here to an early JPA article. Grain yields were adjusted to 15.5 for corn and 13% soybean. I have no idea what that's adjusted what to. They don't add the units. But then what's most disturbing? What's most disturbing is that a whole bunch of articles like this one, where the data is reported in yield and also bushels per acre, but there's no moisture. You don't know what it is. So again, Cynthia or Cheryl, I'm going to pick on you, but you're going to the Jerry's data and doing some adjustments, or that other group, Ag Trials was it, where you're having to annotate some things and do some things and add data because it's not there. Well, what would you pick for grain moisture? Because actually, there's no real consistency across journals and across authors. So it's just scary. We've really slipped. We've really slipped. This is another embarrassment. This is one of my grad students when she first showed up in my office with some of her data. Young adults today think differently, so, and it's good, but this is really free-form data. This has no column headings. Okay, nothing across here that connects these numbers with what the numbers mean. Okay, she showed up, she's so proud. She just has calculations going from here, using numbers down here to come up with numbers over here or up here or over there. I mean, it's completely free-formatted. And this is not unusual. Those of you in the front lines of graduate education, you're nodding your heads thinking, yeah, I've seen this before. This is a nightmare. So I just kept this. She went back. I didn't really scold her. I just kind of smiled and said, well, we need to do this different. Went back and we did this. But what the tri-societies are trying to do is change some of these things. And last year, for the first time, we taught a data management workflows course by librarians, working with librarians, at the Tri-Society meetings for grad students to show them how to think about their data and how to organize it and why it's important. So that's one thing we can do for the data world, is start educating people on how to do data better. And that's really critical. There's people who study the knowledge value of data and how it changes with time. And so we talk about corporate memory with data, and it's really critical. It drops off quick. And we talked a little bit about this yesterday. When you're in phase one, collecting the data, time and distance or both are pretty short. You're in the midst of the study and your knowledge about it's really high. You get to phase two, well, you're on to the next grant. You know, Ray, thank you for sending us more money, and we're on to that project, but we forget about the old project. And our knowledge on that starts slipping a little bit. And then we get a little further out, time and circumstances change, and you're on to something else, and eventually it just goes down to zero. And we all have data sets where you're looking at it and you just don't know what the numbers mean. And if it's formatted like my students was in the previous slide, it's a nightmare. You're not going to figure it out. Then other things happen. People change jobs and it goes even from some knowledge to none. Or they change their professional focus. They go to administration. They retire, some of us. Or they die. But whatever reason, I mean, we lose the data abruptly and forever. And this can't happen. This isn't helpful. So we need to do a better job with data standards. We need to do a better job with the metadata and teaching about this. Minimum data sets were brought up. And so this is, again, from my co-author, Sylvie, who was doing a project that related to conservation agriculture of small holder farmers. And wanted to, the question, this is a sponsored project from the CG system, asking about, is it better to use conservation tillage in these settings? And what are the true benefits? And the point here is that when she got into looking at the 56 published studies on these systems, they found that the critical data on soil, weather, and management just wasn't there. They couldn't use much of the data. They could use bits and pieces, but you really need complete data sets. So the minimum data sets just aren't there. And that's a huge problem. And again, represents slippage. And, you know, a general erosion of the rigor of agronomic research and reporting it's happening. And I think this kind of goes back to a Google mentality. Well, if I don't put it in there, we can always go Google it. I'm pretty sure you can't. And if, like in the previous slide, the person who did the work has gone away, you're out of luck. So the societies are very interested in exacerbating or elevating the rigor of minimum data sets and making sure they're there. Here's just an example of a template that came out of this article that just touches on an example of minimum data sets and something we might want to consider advocating in the societies for articles. And again, we could talk about just weather data, the monthly means, but really if we can get more frequent assessment of the weather, great. Okay. Fertilizers, we talked about including manure, okay, source, nutrient, some of them absolute required minimum data. But but really you also need fertilizer history. If you don't know what the soil test P and K levels are, you can't interpret the response or lack of response. So we need these critical data, these minimum data sets to advance things. Down here, grain yields with water content. We need them. I've just circled a few of these. Oops, ahead of myself. Again, standard deviations and proper statistical values. So we can not only get the means, but get the variation around the means, so we can do some interesting things with the data sets. So yes, there is a role for the tri-societies and minimum data sets and really ramping up the rigor there. I think we're going to do that through the editorial boards, but also will carry over to anything that we publish or do with data. Absolutely. Data publishing. We actually are, these are the guidelines for authors. And so we've got some ideas here for authors to think about. I won't spend much time on those. You'll get these slides and you can look at these. But we've actually got this set up for Journal of Environmental Quality. And I will admit right now that Simon and I we're not up at 2 o'clock like some of the others here collaborating, but I actually picked the same data set from JEQ that he had in his slide set just a minute ago. Kind of a scary coincidence. We also have guidance for reviewers and editors. So we've got some of the background work on what we want in terms of rigor, what kind of data sets and how we want them reviewed. Here's the data set, Simon. Newell Kitchen's a friend of mine. I just picked on his. This is published in Journal of Environmental Quality. Here's the article. There's the data sets highlighted right there with a link. You can go to them. Here's the metadata that goes with it. And there's the data. This is the time step here is every 15 minutes with water flow and soluble solids. This goes on for 6 years. This is a 35,000 line data set. This is a big data set. This is a nice contribution that is here now. Okay, so we're into this. And so we do want to make sure that we publish data sets. The question I have is when we put them in the Tri-Society's digital library, will they be discoverable? Because they're sort of behind a curtain unless you subscribe. And so there's a bit of a problem there with access. But we'll work that out. Will Access publish a data journal? Well, I don't know. There's talk yesterday about data journals in Wageningen. There's talk here about that kind of a thing in the US. The societies are probably uniquely positioned to do some of this if the community thinks it's worth doing. There's sort of a precedence here. This is Journal of Plant Registration, which really publishes cultivar germplasm, kernel stock, things that relate to germplasm. It's effectively an announcement of something, and for plant variety protection, it's required. Okay, so PVP, you've got to go through this process and announce it. And so no hypothesis testing is required. This used to be in the back of Crop Science, the back pages. It was removed and set in a standalone journal. We could do something similar for data very easily if there's the will and the interest. Data education, why data aren't reused? Well, we've worked with librarians for about 10 years about data stuff. And this is from Florian Diekman at Ohio State. Sometimes people say, well, the question has changed. Well, I don't know, questions cycle. We were doing biomass research in 1987. Some of the early work, it came back around in 2007, about a 20-year cycle. And that's what I find for kind of the life cycle for questions. They come back about every 20, 25, 30 years. And we advance them, and then they die, and then we come back in 20 years and advance them again. So I don't think the questions necessarily change. They just get put on ice for a while. In terms of accessibility, poor data hygiene is big. When he interviewed scientists for why they don't make data available, hygiene is on the list. Simply, I lost the data. Okay, this is a librarian talking to scholars, scientists, research scientists. I couldn't find it. Or the technician who had, I think this is lame, blame a technician. Come on. You're in charge. Own it. Put on your big person pants. Technician moved on, or I just misplaced it. So data hygiene, but I also recognize that this actually does happen, and it's a challenge. Other things, lack of data, workflow, and tools. So we talked about tools already this morning. They're desperately needed. Annotation of the data is really hard. Okay, you get a request for data, sitting down and putting all the annotation in to make it usable, all the metadata. It's a task. It's a painful task. I have to explain what I did to everyone. And I think Cheryl said yesterday, they finally had to get together with one group, sit down, because they're trying to do it over the phone or online. And you finally have to sit down with them and do it face to face. That's probably true. We've had to do it as well. It's expensive. 80% of the scientists who interviewed, and this is an article published in Science, said they didn't have the resources to do this. And it really isn't inculcated into our grant programs very well. Okay, the mandate's there, but the money's not there. And then finally, and this is a serious issue because, for example, the Purdue Water Quality Field Station, where we do some work, has over 2,600 data files. That's a lot of data. And to get all of that prepared for broad use is difficult, and that's a task. So it's a question of money, motivation, and mechanics sometimes, but it is very important. Data education is what we're hoping to use, at least at the Tri-Societies, to deal with some of these reluctances, some of these challenges. It's coming from Cochrane Collaborative. We'll talk about evidence-based healthcare and how data really feeds into that. Very interesting talk. And again, Simon mentioned healthcare and NIH. I'll give an example of what this Cochrane Collaborative is doing at Johns Hopkins. But it's very powerful for evidence-based agriculture. Coming from agriculture can take advantage of it. Our own Cynthia is coming. Is coming to talk about AGMIPS partially, but also to talk about her experiences in getting data into AGMIPS, the challenges and the barriers. And it's not trivial, so that our members can hear this and can learn to participate. And then Larry Madden's coming from Ohio to give a day-long workshop on meta-analysis and how one can use data for these kinds of activities. The goals here really essential element. Wasn't a very good steward to begin with. By the way, she now works downtown on the Hill. I don't know if that's good or bad. As an advisor to Congress. To also illustrate how reviews and literature analysis supported by data could have revolutionized medical research. And I want to go through one example. And then about data stewardship in ag can really leverage what we do as a community, not only in modeling, but also just in on the field with these CCAs and things of that nature. So let's go through a very quick example of something from the Cochrane Collaborative. This happens to be streptomycin intervention with heart disease and people having heart attacks. Individual studies are listed right. Go through 1988, and can you now? Okay, and what each of these gives you the mean and the error bars around the mean, and a value of 1 means no effect, and if the whiskers extend across that vertical line, there's no effect of the study. And you can see when taking each study by themselves, they usually cross this magical vertical line, and they're not significant. Okay, but what happens if we, instead of doing, and that's very typical of agriculture, we'll do a fertilizer study or something else where we'll have a whole bunch of separate studies and most of them will be not much difference. If we start aggregating and doing cumulative meta-analysis, where you take the first study and add it to the second study added, first and second added to the third, and likewise, and really start taking that data and building knowledge from it. It doesn't take long in fact, in 1973, the mean and the whiskers weren't touching this vertical line anymore. It was a significant response in 73, and every cumulative result after that, when added to it, made it even more significant. Okay, it means that this treatment is really something we need to be doing. Unfortunately, this wasn't done early enough, and that it took 20 years of studies like this before somebody did this and came to that conclusion. So, using cumulative analysis in the landscape in agriculture really has an opportunity, I think, to be a sea change in terms of decision making, not only to make agriculture more profitable, better for consumers, but also when it comes to regulation. If we can point to, justifications like this for what we're doing on the landscape, we're in a much better position with EPA and others. Here's an example that was from that same Cochrane Collaborative that was in the press about a year ago on Tamiflu. If you're watching the news or watching the CBS Evening News, the Cochrane Collaborative had done a similar study with Tamiflu and showed that it has little effect on the pandemic, should there be one. The value in all of that is that on our behalf, the government is storing about $1.3 billion of Tamiflu in a warehouse in New Jersey, should we have a pandemic. Well, it really isn't that big a threat because The analysis indicated that the symptoms reduced by 17 hours and no effect on mortality. So again, you can do some really useful, money-saving, thoughtful analyses by having the data. And that's something that our CCAs and certified professionals really want access to. So the Tri-Societies is very interested in aggregating data and providing the tools, not only for AGMIPS, but to do some of these other things that the health community is already on. So we're going to evolve from being an eminence-based versus evidence-based system. Eminence being, you know, I'm from Purdue, I know everything there is about alfalfa or biomass, just believe me, okay? And a little cartoon up here has some poor student, you know, struggling with his eminent person. And really, it's not about doing anything about a textbook, review article, or journal. It's updating his Wikipedia entry, okay? So it's kind of sad. So if we can move from eminence to evidence, we're really on much better footing. And so agriculture, I think, will be like medicine, where they take the best research evidence, clinical expertise, marry it with patient values, and get evidence-based healthcare. Again, with agriculture, best research, management expertise, stakeholder priorities, evidence-based agriculture. Again, something for our community to work on. Repository issues have been discussed, and I'll just not beat this horse other than I think a distributed repository is a good idea. I think for many of us with a wrinkle or two, you remember, you know, this is how we data, file cabinets. I was all excited. I was talking to Jeff White, and we were reminiscing about cards. Anybody remember data cards? Yeah, cards. Then we got tape, okay? I didn't have pictures of any tape, but remember, then we went to 5 1/4 discs right here, 3.5-inch discs. Remember zip drives? iOmega zip drive, 250 mega. I was on top of the world, man. Everything I knew fit on that, right? And then to these things. Well, it's a much different world. And cloud computing and putting these things in a repository, none of this is available here, really, or here. But if we can put it in one of these repositories, it's great. And I look forward to the new Ag Data Commons. And Access is interested in repositories, but may not create a repository itself. I mean, there's some reluctance because of the overhead. So going forward, you know, I think Access is going to continue to work with stakeholders, AGMIPS now, but also industry people. I've got to leave the meeting early to go over to go downtown to talk to the fertilizer industry leadership about data. They've actually funded some projects, and as a requirement of those projects, they've got to make their data public. This is a private concern, wanting the researchers to make the data public, and they're withholding funds. 15% of the money will be, the last 15% will be released once your data's made public. So again, they're using a carrot stick kind of an approach. It's that important, they're putting teeth in it. So I've got to go down and talk about data to that group. We're going to probably improve the editorial process and come up with best management practices for data standards and metadata standards. It's sorely needed. We've gotten a little loose. And there's many reasons for that we can talk about. Education programming relative to data, we're going to continue that. Also in the context of the new NRC report that just came out 2 weeks ago on preparing the workforce for digital curation. So that's in that context, look at that. Look at a data journal, I just don't know. It's up to the will of the organization, but certainly that's on the table. Work to resolve repository issues with stakeholders and people. And finally, develop a sustainable business model. You know, one of the challenges, who pays for this? You know, professional societies have to have a sustainable business model or they will go out of existence. And so they just can't do it gratis. Same with any other organization. So we've got to talk openly and honestly about what this costs to our stakeholders and others to try to get the support to do this if we truly value it. So, Jim, with that, I'll close. Take a question if we have time.
So yeah, we have that. Question in the back. Microphone.
Journal. And there's a lot of those papers, there's a percentage of this published and percentage is declined. based on the judgment of reviewers that you send the paper, and all of us done that. That's where a lot of good data goes away, and that's become hidden and never comes to surface, because maybe for the format, maybe for something, the international writers that did not write the paper well, whatever the reason is, depending on where you give this paper for publication, those data goes away. Is there any plan that these societies talk to the authors and says, your data is great, and here's places, at least we give you some guideline to archive your data for people to can use this for different parts, for whatever you're here for? Is there anything like that?
So I think there's some reluctance on the part of the societies to create a data repository. I really do think there is, because of the overhead. I mean, it's a serious, like, you could quiz Simon, but it's $5 million a year to get a big data program going. I think there's some reluctance, unless there's a lot of will on the part of the members to do it. And keep in mind that, we're kind of preaching to the choir here. Okay, if I go into the General Assembly of the Tri-Societies and talk data, I will get a mixed response. And I would say the preponderance will be, they're not that interested. So I don't see a data repository showing up soon. However, for those data, but I think your point is well taken. I think the value of data is today versus what it might be 20 years from now is quite different. And it's difficult to judge today what is valuable, not valuable, when one looks down the road and just pitch it. And so I think we've got to be very mindful of what is a valuable data set and have those open conversations, okay? I didn't talk much about the repository systems because of time in between you and the break. And with my minor extension appointment, I know what that means, get a hostile crowd. But I do think there's room for repositories that aren't tied to publications like Dryad. The downside of Dryad is you've got you've got to have a publication and then the data set that goes with it, and only that data. Well, that's okay, but it does leave off some of the data that you're talking about, okay?
But in response to that question, you can put your data elsewhere. For example, Figshare will give you a DOI, and it's there and you can access it. So it's not always down to the societies as well.
Right.
There are other options here.
And now may be an option.
Yeah. So, I mean, you should, think beyond some of these as well. There are other ways you can get a data site. And obviously, if you have Ag Commons, then there's a way to do it here as well. So I think, there is some responsibility from the community to also find ways to highlight this and signpost where these things are, or provide education via the Tri-Societies on how you might be able to do that through their workshops and meetings.
Yeah, following up on that, and I was going to talk after this with some suggestions for Simon's talk as well. I think for the repository of the data, there are a lot of journals that have started coming up, like BMC, Data Science, and Nature also has it now, especially only on data. There's no analysis on it, just disclose the data about it. But the other way could be is that instead of people running all the analysis on their desktops, if it's a cloud computing infrastructure, through NAL's resources. For example, you analyze your data sits on the cloud, and whenever you're ready, you make that link open. Otherwise, data sits private, and that data is immediately accessible and tied to all the metadata and the publications right away on that resource. So that's how I think iPlan Cyber Infrastructure has helped people have their own data storage sites within the virtual machines, and then they analyze it on it. And whenever they're ready, those files are accessible and with a DOI on it. So
that's how the Per University Research Repository works, is a workspace,
yes.
And then you can release it
yes.
to the public with a DOI.
That could be one possibility of doing it.
Yeah, I wanted to comment on these repositories, that particularly the ones that are being done by the journals and things like that. I mean, the formats there's no requirements on formats, and there's no standards on that, or even the metadata. And I think what we have a chance to do here is, through what Simon was talking about, is to create the metadata and harmonize these so that the data will be usable. And so I think that's a big step in what we as a community can do and should do.
Right. I think that's an excellent idea, and I'm working with the American Society of Plant Physiologists and Plant Biologists on which publish Plant Cell and Plant Physiology on standardizing some of the supplementary data files that they have to be deposited so that we can use, analyze the data and things like that. So that could be an opportunity.
Listening to Jeff's presentation and even Jeff White's presentation yesterday, we've talked a lot about policies and technical approaches or engineering approaches. But what I'm struck with listening to Jeff is the capacity building that needs to be done on the science end and also on the government end in the communication that goes on between science and government. And Jeff had his Tri-Societies hats on, and I've been sitting here thinking about institutional mechanisms, at least in the government, to be able to share information. There are things like the Intergovernmental Personnel Act, where the government can hire people from outside, perhaps the university system, to come and help share technical expertise and build capacity internally. There's also, I used to work with Ray and Nancy at NIFA, and I was exposed to this group of organizations called the multi-state committees, which are, I believe, authorized under the Hatch Act. Is that right? Right. And the committees are wonderful committees that have collections of expertise in various domains, and they provide. It's an information sharing organization or groups that can also provide guidance and contribution to government. So I just wanted to share those thoughts in terms of thinking about ways to build capacity to meet some of those challenges that Jeff described.
I suppose I'm just preaching to the choir, but when you're talking about publishing the unpublished data, it just makes me a little nervous. We still have to have some kinds of quality standards. And partly I have experience when I worked for ARS as a scientist, and I went to the B Lab in Logan, Utah, and whenever I would start a project, there was a technician there who had been there for 25 years, and he said, oh, you know, we did a good experiment on that a few years ago that you could put with your data. And he would dig up the data, and this happened to me many times. And I was like, oh, wow, that's really great. I'll have some old historic data to add to my experiment. But there was always something wrong with that old data set. There was a reason why it wasn't published. There wasn't a proper control or, you know, standards or replication or something like that. So using the, you know, it's easy to say if the data has a paper that went with it, it's been publicly scrutinized by the scientific community. When it hasn't gone through that, you know, how do we determine what the quality of the data is?
You know, I think your comment is well taken, and I think that is one of the real values by interacting with the modeling community, and the whole thing on grain moisture content came to light for us inadvertently when some ag economists were using some of our data. They assumed 15.5% moisture, and it was actually listed as 0% moisture in our data sets, and so their models weren't working. And so this, when you start interacting with other groups who are data users, and you've got data I mean, it's a fascinating interaction because these things become apparent very quickly, and that's very helpful. So I think this is one of the real benefits of the interactions that we're having here this week, and should continue these going forward.
Okay, thanks again, Jeff. We're going to take a break now, and I think there was to be a picture. Is someone ready for the picture? Simon, do you know who was set up to do that, or where we would be taking it? Okay. Okay, so we'll do that before lunch. But anyway, let's come back in half an hour, yeah, at 15 till 11. And then we'll have the presentations by Carol Barford, Ali Saleh, and Ezra Pine. And then we'll go to breakouts. Thank you. Very good. And these are for dairy, beef, life cycle analysis, and maybe biofuels or energy data. So the first one is going to be given by Carol Barford. Carol?
Anybody see where my presentation icon is? All right, thank you very much, Jim, and thanks to all of you for the opportunity to talk a little bit about the dairy cap and specifically about data and metadata needs for the dairy cap. The overarching goal of the dairy cap is to find better ways to find good ways to reduce the greenhouse gas emissions of dairy production in the U.S. and also to find adaptations to possible climate futures for dairy production. So the test case that is being used by the dairy cap is for Great Lakes area dairy production, and for field sites, we have most of our field sites in Wisconsin and a few different places, at Penn State University and also at Cornell. So that's covering a pretty big swath of the Great Lakes. We also have investigators in the dairy cap from University of Washington, from University of Maryland, Cesar, who was here yesterday. And we have partners, many partners in ARS, and also, I'm forgetting a couple of agencies here, I know. But our big partner in industry is Dairy Management International. And the dairy industry is under some pressure, as are industries that focus on foodstuffs, to demonstrate the sustainability, the environmental sustainability of their production and their products. And so there are customers of dairy, big customers such as Walmart, Starbucks, and Dannon, who are very interested in being able to benchmark the sustainability of their products. And so through, and Dairy Management International is creating a benchmarking tool called FarmSmart, and that's connected to the activities of the grant, both the data gathering, the modeling, and LCA activities within the dairy cap. So this is a broad look at the dairy cap. We have 3 kinds of field activities looking at greenhouse and focused very much on greenhouse gas production. So we have 3 kinds of sources of greenhouse gas production in our field activities. One is cows themselves and the barn. Another is manure, and the other is soils that have received applications of dairy manure, and also perhaps other mineral sources of N, P, and K. So the data from these field experiments is going into process models. We have our own model intercomparison, kind of parallel to AGMIP, I guess you could say, going in the project. And the outputs of this process level modeling activity is going into to inform LCAs of dairy production, most only liquid milk in our case. There are lots of LCAs of dairy production, as you could imagine. And our LCAs are very much ending at the farm gate. So there are many complexities of the overall dairy system that we could be addressing, but we're sticking with the farm gate. So as outlined yesterday for the wheat cap, there's a broad range of outreach activities, education, and like I just mentioned, a decision support tool for industry. So we also have on there our participation in the NAL repository, and I'll show you now how we're trying to make that work. Sorry, you can tell I'm an Apple user. I'm struggling with the struggling with the Windows-ness. So, like I said before, there in our experiment in our project, there are, we're looking at 3 kinds of sources of greenhouse gases: the cows themselves, and that means eructations and flatulations of cows. So, and these are being measured in whole cow chambers. So we're serious. This is the technology being used to actually get at this kind of greenhouse gas flux. Also from manure. So what does that mean? That could be both land applied manure and also microcosms and mesocosms of manure digestion, because there is bioenergy industry associated with manure processing, and there are lots of different ways you can tackle that, lots of different fractions of manure that need to be investigated: the liquid, the solid, the slurry, with the bedding, without the bedding. So those are the kinds of fluxes we're worried about from manure, and then also from soils under different cropping systems, especially the traditional kinds of rotation that include forage that are particular to dairy, and with a very specific range of manure application techniques and implements that put the manure in a different relationship to the soil and need to be investigated in terms of greenhouse gas production. So for our soils, we're thinking about how do we document the greenhouse gas fluxes from the soils and the metadata that needs to go with those fluxes. And a lot of our investigators in the dairy cap are already part of the GraceNet project through the USDA and are already familiar with the protocols for collecting data, collecting greenhouse gas data and metadata. And so they chose to use the GraceNet input template for the data. And as it turns out, that's a very nice fit, and most of the quantities that are needed by the modelers in our project are already represented in the GraceNet template, and that seems to be going okay so far. I just looked to see how the grain moisture is represented in GraceNet. They want 0%, so it's in tiny little writing, tiny little faint writing, 0%. So I'm glad that's been flagged. So soils, that is coming along well. Cows. So what kinds of data do we need to worry about with cows? In many ways, in the dairy cap, a cow is analogous to a plot in a crop system. It has inputs, it has a state, and it has outputs. So, and this is how it was explained to me by a guy who works on cows. So I'm pretty confident that that's one way that you can put it. But there are lots of things in here that I have the feeling are not well represented in ICASA or in that are commonly used in AGMIP. For example, the rumen. Lots of things going on in the rumen of cows. It's very important for the outputs of greenhouse gases, what's going on with the fatty acid metabolism in the rumen. How do we represent that? Do we need SI units for the fatty acids in the rumen? How does that work? There are other things that are particular to cows, their health, their status, their lactation status, things that we need to pay attention to that are super important in terms of interpreting our data. Very important cow outputs, not only in the milk, which is of great importance to the industry and for looking at the nitrogen budget of the cow, which is a subsidiary goal of our project here, is to look not only at greenhouse gas production, but feed efficiency. So how do you represent all those things in SI units? And what is the burden of the metadata creator, which is me in this case? What is my burden in terms of finding an SI unit or some other very transparent primary unit that everyone can understand for quantities that may or may not be very commonly used? So where's the borderline in terms of finding a really, really great unit versus putting it out in the database and having some text that kind of describes it and going and moving along. So that's a discussion that I'm eager to have with people who have worked with data. Next, manure. What kinds of data are coming out of our analyses of manure? Well, it's harder to represent in that nice classical input, state, and outputs sort of framework. But surely there are a lot of things that our people in the dairy cap are investigating in terms of manure status. Many elemental pieces of elemental concentrations. The person, Becky Larson, who is in charge of our manure experiments, who is the lead, is she's an engineer, and you can tell. And how, what is the burden in a database of representing all of these quantities and keeping them for the posterity that may in the future somehow be interested in manure aluminum or manure iron, which even the modelers right now in our project are not that focused on. So we have in some cases a very close match between what modelers want and what the field folks are providing. And in some cases, we're going to be archiving data for posterity. So thinking about that. So that is, those are the data concerns. I just want to acknowledge the folks at UW-Madison who've been thinking about these data topics with me, and looking forward to picking all your brains a bit more. Thanks.
Okay, next we have Ali Saleh.
Good morning to all, and thanks for being here and listening to this part of the talk. I'm representing the grazing cap. I'm just one of the co-PI, and I'm in charge of the LCA and basically footprint. But when you are in the LCA section, you get to work with every group. So because we have to put it at the end together and create an interface for the user to get into the system. Our work, I'm just going to talk a little bit about background. The area of interest is going to be somewhere in mostly Oklahoma and Kansas and in part of Texas. And we have the collaborators from Oklahoma State University, Kansas State University, University of Oklahoma, and our tier Texas Institute of Applied Environmental Research, part of Towson State University, USDA ARS in El Reno and Bushland, and the Nobel Foundation, Samuel Nobel Foundation. So this is a wonderful group to work with, and the experience is about, I think, 45 to 50 scientists involved with this. So we make sure that work that comes out of this is going to be very much verified by all. And we have a number of advising groups that they check our work, and public and private partnership is very much part of this. Nobel Foundation plays a significant role because that's where we can connect us the science to the public. And they are very much involved with a lot of producers in Oklahoma and Texas and some part Kansas. So we have in our team agronomists, animal scientists, engineers, soil scientists, sociologists, ecologists, meteorologists, economists, and extension personnel and producer and collaborators. I would emphasize on economic because after all, farmers are for making money. They are not in the business just to lose money. So we need to have economic evaluation, whatever we do that makes sense to them, and make decision based on that. So the impact of this study is the per capita about 28 kilogram per year of in America is being consumed, and need to feed every increasing population coming up, and $44 billion economy. It depends on the cattle, and more than 50% of the cattle are in Texas, Nebraska, and Kansas, Oklahoma, and California. That's why this area study is very significant. The rationale for this study is the drought impacts on the beef cattle grazing alone about $5 billion losses in 2011 Texas. So we have to do some strategy to make the farmers to survive through these drought conditions. Climate change may lead to significant impacts of agriculture production, of course, and the greenhouse gases emissions is part of this global changing that is happening, climate change, and we need to address that. So objective of this study was reduce greenhouse gases emission from beef grazing, evaluate the mitigation strategy to address climate change, impact on agriculture production, especially beef grazing operations. Why do I say agriculture production? We will show you this slide here that the farmer is not going to be emphasizing on one piece of the land, is the enterprise. He needs to be worried about everything happening in the field. And that's what we approach, the view we have about this project. And evaluate the impacts of climate change on beef farms' viability. If you look at this slide, basically, some of the things we're doing here, footprint analysis, LCA, and experimental work and economics and biophysical modeling. So we're looking at this thing as a farm, not, is that the one? We're looking as a whole farm, not, we did not say the grazing land, because that's the enterprise that we have to deal with. And within this farm, we're looking from the moment, we're emphasizing mostly on cattle, from the moment the cattle is born and the moment goes to the slaughterhouse. That's where we are doing the LCA and looking everything comes into the farm and what goes out as a production and also as a gases to atmosphere. Components of this study is a data development team, which Dr. Chuck Rice was supposed to be here. I'm representing him. He wasn't able to. So that's where they're going to be looking at the sites within the Oklahoma and Kansas that really doing a lot of the stuff that very technical and state of art of monitoring system that we have a field day and we're welcome to join them twice a year to show the people how they are collecting data. And this is for measuring and monitoring storage and fluxes of water, carbon, and nitrogen in cow, calf, and stocker systems utilizing combination of winter, wheat, pasture, and rangeland forage. And then also number two is the theme two is the footprint estimation, that the standardized methodologies for estimating carbon, nitrogen, and water footprint of this southern grain plain beef cattle farms, and for evaluating feedback and linkage between changes in the agriculture production system with human behavior and decision making. Theme 3 is the baseline determination, established baseline for carbon fluxes, energy, nitrogen, and water use and storage. And theme 4 is going to be scenario development of suite of existing and novel approachable and management practices leading to a net decrease in the footprint and increased carbon sequestration in the mixed beef forage farms. And the life cycle analysis is theme 5, which is conducting the comprehensive life cycle analysis of mixed cow, calf, and stocker cattle production farms. We just introduced the water portion of this in the last ASAB climate change meeting in Chicago. And energy. So some of the strategy, I don't want to go through this, some of the strategy you can see is the example of mitigation regarding cattle production. For example, if there is going to be some problem with the cattle production, farmers need to go to other piece of land that has access to the farm and deal with that to compensate for losses that happening in order to in the cattle production in order to stay in business, or vice versa. So that's what we are looking at. So not only we're looking at the strategies on the regarding cattle production, also with strategies and mitigation strategies for other land uses, corn, soybean, to obtain maximum production at the farm level. And that's why our modeling system has to be comprehensive enough. This is what's really happening in the farm. And if we cannot handle all of them, farmers are not going to have trust in our production. So we need to gain trust in crop yield. We need to be for different operations in the field. And that's why we are looking at the whole thing. So here's our modeling system. I don't know, this doesn't work, but oh, there it goes. There's going to be biophysical models, and we call soil plan. In this case, we are using NTT for those who don't know, but nutrient tracking tool. This is something we work in NRCS to apply in US and in Chesapeake Bay also. We're doing a different nutrient net in that. So the Apex is the main components of it, but we are going to add DNDC for other outputs that the Apex is missing right now to compensate for it. So we have animal models that is coming from, the from bushland group that there are going to be, as the previous speaker said, we're going to put the cattle in the room and then get all these measurements and come up with the models that can compensate when the animal is sitting on the grazing land. And then the economic model, farm economic model, which is, this was generated, built in our station with Dr. Osei. So very comprehensive economic model that deals with everything that goes on in the farm. And then we have the satellite modeling that there's a vegetation photosynthesis model that is going to be estimating GPP and NPP. And ET satellite imagery, this is something that the people in Bushland in ARS working on. It is going to be a new method of calculating the ET, capturing ET in the field by using the satellite imagery. The field research so of course, there are going to be all the calibration and verification of process we do here is the field study is going to be verifying it. And within that, the data is going to be generated. And whatever the data needs for these models and whatever is generated and verified through the field study is going to be available for the public through this interface. So in the output of this, for producer and researchers and whoever wants the data, economic impact, profit and cost of resources used, crop production, carbon and nitrogen and water and LCA and all this information that comes out of this as explained about the objective of this project going to be available as form of data or decision-making tools. A little bit about NTT I want to explain to you. Current NTT, which anybody can get access to right now, you can run it on your phone and you can run it on your computer, tablet, whatever. But it currently has Apex and FEM to associate databases directly, and there are quite a few data already goes to this Apex, this NTT, like a soil database, weather files, and all those modeling requirement database already goes to this program and is available to public. But then the future version is going to be once all the modeling system get together through this entity and become grazing cap model entity, is going to host all these models, and the data and every process that goes through this model is going to be available to public. Okay, almost done. The last slide. This is show you some of the NTT program. This is a new soil survey site that we have created for ourselves because government shut down, the format the soil survey goes down slow and so on. So this is a Google map system that we access through that to get soil survey, and every 6 months gets updated. Here's the mapping system, how you can divide your farm to different sections and deal with it, and you can get information into it and getting the databases. We even, for example, we have all the zones of management zones that NRCS has for Russell is there, converted to the program of Apex. So all of this information will be available. We'd love to share that with the group. Thank you.
Okay, Ezra, did you have a PowerPoint?
Keep track of time, not to check my phone. Great. So my name is Ezra Khan. I'm a technical information specialist here at the Knowledge Services Division at the library. I'm going to talk about the data, but I'd like to take just a couple of seconds of my time to thank you for the invitation to come to this workshop. It's been a really great experience for me to learn about what you're doing. And it's also really timely to the work that myself and my colleagues here at the library are doing in the LCA community. We're having the same discussions about how do we share data, how are we going to reduce the duplication of our efforts across, well, in our case, federal agencies. There's a lot of people doing LCA, and we want to work together to try to bring our resources together to make data access and reuse a thing. And so, yeah, so I'm going to talk specifically about our data today. We had mentioned a little bit about life cycle assessment. Just quickly, if you're not familiar with LCA, it is a systems analysis tool for measuring your environmental impacts across your supply chains. And you do that by well, the main way that we do it here is by considering individual processes from resource extraction through the production of some kind of value product and to a consumer that uses that product, and then the end of life where we landfill or recycle that product. And we take we consider and quantify all of the emissions at each of these processes. And so we can produce an inventory of emissions that we can then map to impacts and try to then make some assertions about the sustainability of our product system and compare it to some alternatives. So that's the idea of LCA. And the LCA Commons data set is individual unit process data sets that have been developed to support life cycle assessment, particularly for agriculture. And we have worked with an academic partner at the University of Washington, Professor Joyce Cooper, to come up with individual gate-to-gate unit processes to represent major commodity crops. Cotton, peanuts. And we are also working with researchers at the University of Arkansas to develop, well, we have data from them representing dairy production as well as swine production, and we are working to curate those data sets to merge them into the LCA Commons. And so it's a collaborative process to make sure that the data that they're giving us is consistent and well documented, that it will come into our system cleanly, and that the people that come to take it can make good use of it. We're also working with the Woody Biomass CAP. They've submitted some poplar data that they would like to archive with us at the Commons. So some more details about our crop production. We have the crop production data explicitly outlines the activities on the field that are involved with producing a unit of grain, and so we inventory the machine activities, the applications of materials, including these pesticides and manures, water, seeds, and we also have to estimate the transportation distances of moving all these materials from regional store points to the farm. And so this data set in particular is a statewide average that representing the last 20 years of crop production. And that's reflected by our data source. Our data sets are built upon NAS surveys. So we add value here at the library through our metadata and our database and web applications that we use to disseminate that data. The LCA Commons is built on the Open LCA framework, which is an open source modeling tool that comes with a database, and that database has metadata fields that fully comply with our main metadata standard, ISO 14048. And so we've written explicit guidance for reporting metadata that supports data discovery and supports the applicability to some new studies. And so these are some of the topics that we have to include in our metadata to make sure that researchers interested in reusing these data sets can do so in an informed way. So that includes the actual physical representation of what this unit process is, the system boundaries, and then there's also subjective choices that are involved with LCA. LCA is a tool, and so it's We have to communicate things like impact methods and how byproducts and co-products are managed within the model. And then we also, report our data sources and the people that are involved with the project. So I thought that it would be worthwhile to mention that LCA and what we consider LCA data is in fact a data model. We, similar to what Cheryl mentioned about DOME and uniformly applied assumptions, we're bringing together data sources that were developed independently and were not necessarily intended to go together in this kind of a context. And so each time we bring together a new source, we have to complement that with expert opinion, with literature reviews, and of course with the engineering principles that underlie all of these processes. So what we have here are a couple of different of the phases within a crop production model. We have the actual growth of the crop, which is we get the data from ERS's ARMS survey, and we supplement that with NAS Census of Ag Statistics. The machine operations for producing those crops, we use some NRCS tools as well as some additional surveys from NAS. And then to estimate the emissions of running those machines, we were using an EPA tool. So at each step of the way, we have to integrate this data together, and it takes an engineer to do it. But when we do it, then we come up with we come up with a model, and so our data is represented as these basically a generalized parametric model that maps the individual variables that we got from our raw data and maps them to the LCA exchanges, which are the flows of material and energy that you can consider in your analysis. And we do that through these parametric models. So in principle, we could replace these ARMS variables, which are very general and very broad, and perhaps hook them up to something like the NTT tool to narrow in the scope of a study, because we've developed these relationships here. So, and similarly, life cycle assessment is a multi-phase, multi-step assessment. After you have the inventory worked out, you then need to determine the impacts to the environment of this emissions profile, and that involves more models. So what I've got represented here is on the left. This is some high-tech pesticide application machine, and so the pesticides are applied to the land, but then they go somewhere. The pesticides degrade, and their degradants are transported into various environmental compartments in which they then impact the environment and society. And so there's different ways to model those things, and this could be nitrogen as well. And Ali mentioned the DNDC model for modeling these things. So we stop at the application of these pesticides and fertilizers, basically everything that's applied to the land, so that the modeling community could, in principle, hook up different types of fate and transport or nitrogen balancing models to this tool. So this is another place to interface between LCA and the broader modeling community. So that's all I have to say about that. Thank you very much.
Thank you. I'd like to thank all three of you for making these presentations. I know you'll be working in breakout session 3 this afternoon, and hopefully coming up with more specific recommendations on a part of a roadmap that needs to be followed to take these initiatives forward as well. One of the things that struck me about these is that all of you are using models, and these data are essential for providing inputs to those models, and also curating the outputs from the models, and they link together. And I can see some good interactions, as you mentioned there, also with some of the crop modeling and livestock modeling and so forth, particularly if you're doing strategic foresight analysis, looking at future things. So that concludes our session this morning. We're going to have our breakouts start now, but before I do that, Nancy Cavallero is going to make a comment or two about the draft data policy, right? Is that okay? So I'll let you can tell us.
Yeah, so Ray Knight and I are here from NIFA. We're program leaders, and talking about the data policy, and you can this workshop can come up with comments and recommendations, et cetera. But one of the things that's going on right now is we're working on next year's RFAs, so request for applications, and we've been talking about in our discussions about how we can facilitate as funders this data management and curation, et cetera. And so it occurs to me it would be a great outcome from this meeting, or it could be each of you individually could send us to officially stakeholder input into our RFAs with regard to this data, these data issues. You can send it on anything else you want, actually. Every RFA we put out has a section that says stakeholder input. We solicit stakeholder input, and the deadline for submitting this input on the RFA that's currently out is 6 months after it's released. So, but we're about 3 months in, since most of the Agriculture and Food Research Initiative RFAs have been released, and that's who funds these CAPs. So it'd be great if you could think about putting something together collectively or individually. And so what you can do is you can go to our website and click on the grants and find the grant that you're interested in, and click on View RFA. Don't click on the PDF because that'll be last year's RFA. Anyway, and you'll find information on how to do this. But all you have to do really is send an email. Send your comments in an email to the NPL of interest, or one or the one listed in the RFA, but also send it to make it official, policy@nifa.usda.gov. And you'll find that in the RFA. That's where it says to send it, but I suggest that to make sure it gets to the right people, send it also to one of the NPLs. Ray Knighton or I will be fine for that, okay? Is there anything else, Ray, I should say about that? Okay, just wanted to put that out there, because really we're working on the next year's RFAs right now, and it'd be really good timing. Thanks.
Yeah, Nancy, thank you. That's actually fantastic. I mean, that's one of the things that we're hoping to do here. And in fact, our breakout session 4, you may want to sit in on that and listen to some of the comments there as well. But we'll certainly send you comments. Yeah, Pat, did you have a Nancy Cavallero? Yeah. Okay. So we're going to go to breakouts now, and I have a couple of announcements. Let's see. We're going to have a picture taken at 12:30. So we'll be doing breakouts now, and then at 12:30, please be down here in this room so that we can have group picture. And there'll be a photographer here to do that. So at 12:30, please be here. And then the breakout charges are similar to yesterday the same for breakouts 2 and 4. And then breakouts 1 and 3 will be meeting here together, as opposed to separately this morning. And there will be a presentation and discussion, joint discussion about vocabulary and data and so forth. And so, Cheryl, will you be leading that? So Jeff and Cheryl will be leading that. So that will be breakouts. 1 and 3 will be meeting here, and 2 will be meeting in the same place as yesterday, which is around the corner, and breakout 4 will be meeting upstairs. So we'll have 1 hour, and then we need to come back down here at 12:30 to have picture taken, and food will be available again. And so we'll look forward to seeing you. Okay? Thanks.